All right, welcome back. Okay, so now let's talk about this quadratic formula. So this, or function. So this is the example. So this is what we're given. And so now we're going to answer some questions about this quadratic function. So the first question is does the graph of this quadratic function, which is again a parabola, does it open upward or downward? Well, notice that A is negative. So that means it's going to open downward, right? So this is going to be a downward opening, right? So it opens downward. Now we want to use the vertex formula to find the vertex, right? So in this case here, now we could put this in vertex form, but they don't want us to do that. They're saying, hey, use the vertex formula to find the vertex. So in this case here, remember, x equals negative b over 2a. Now remember, what is b? B is 4, right? So that means this is going to be negative 4 over 2 times a. What is a? Negative 1. So now, if we simplify this, right, this becomes what? This becomes 2. Right? We get negative 4 divided by negative 2, which gives us positive 2. Now what we're going to do is that's only part of it, so now we've got to find f of 2. So now if I plug this in, I get negative 2, quantity 2 squared, plus 4 times 2 minus 5. Now again, be careful here, the 2 is inside the square function, right? So the negative sign goes outside the parentheses. Okay? So now that means this is going to be negative 4 plus 8 minus 5, which equals negative 1. Right? Negative 4 plus 8 is positive 4, minus 5 is negative 1. So now the vertex is easy now. It's 2 comma negative 1. That's our vertex. And that is the answer. Okay, x-intercept. All right. Where is the x-intercept? Again, we set this equal to 0 and solve. Okay. Now we could do this a couple different ways. We could see if it's factorable. Okay, so again, factor out a negative 1. So I would write this negative 1 times x squared minus 4x plus 5. And this is not factorable. You could see that there's no product of 5 because it's prime. That will give us a negative 4, right? Because it's just 1 and 5. And since it's positive, this is both, the factors have to be either both negative or both positive. And in this case, they have to be both negative, but that won't give us a negative 4. So this is not factorable. So we can't do it that way. Okay, we could use the quadratic formula to find the x-intercepts, right? But you know what? Let's use the vertex form. Okay? So let's do that. So let's put this in vertex form. So what I'm going to do is I'm going to group the negative x squared plus 4x plus whatever. And then I'm going to stick the minus 5 out here. Okay? I'm going to factor out a negative 1. So let's factor out the negative, make this positive, and then make this a subtraction. And now again, we don't have to change the sign here because we're always going to have a plus here because we don't know what's going to go here, right? So don't worry about changing this. We're only affecting this at this point. So now we have negative 4 divided by 2, which is negative 2. We square it, and look at that. We get 4. So remember, it's always going to be positive because we're always going to be squaring this term here too. Okay? Now, okay, now remember, whatever I add here, I have to add or subtract out here. Now, but remember, I have a negative here. So if I distribute the negative to here, that means this is going to become a -4, which means I really have to put a +4 out here. Okay? Don't ever forget about what you're factoring. If you ever have to factor something, you've got to make sure that you're distributing. So you got to keep that in your mind. Okay? Now I've got a perfect square here, so this is going to become a minus, a negative quantity. So it's, let me rephrase. It's going to be a minus of the quantity x. What is this? -2, right? Because I take half of the middle term, quantity squared. So now that's the perfect square. Now this is going to be a -1. Okay, now if you ever want to check to see if you did it right, again, always check if you ever have doubt. So redistribute this, right? So if I go backwards and I expand this out, this is going to give me x squared minus 4x plus 4, right? Boom. And then if I distribute the negative sign, I get negative x squared plus 4x minus 4, right? The -4 cancels with the +4, and I end up with my -5 back. And so I end up with the same thing. So we're good. We're good. So now that I have it in this form, now I know what my vertex is. By the way, notice the vertex is 2, -1. Right? So it verifies what we got here with the vertex formula, which is cool. Okay, now, what was the point? Well, we're looking for the x-intercepts. So we're going to set this equal to 0, and now we're going to solve for 0. Okay, so let's do that. Okay, so now, let's set this equal to 0. So we get negative x minus 2 quantity squared equals to 1. We'll divide both sides by -1. So we'll just flip the negative over here, right? And then we're going to take the square root of both sides. And we get x minus 2 is equal to the square root of -1. And look at that. We get the square root of -1. So immediately I'm going to stop, because as soon as we get a square root of a negative number, we know that we're dealing with imaginary numbers, and this tells us there are no real solutions to this equation, which means there are no x-intercepts. Okay, now we went through that work, but let me share something with you, because we could have avoided all of this if you just notice something, right? So let's go back, right? So let's go back and remember, where was the vertex? The vertex is at 2, -1. And from the part A, how does it open? The parabola, opens downward. Well, where is this vertex located? Is it located above the x-axis? Is that vertex located below the x-axis? Well, in this case, it's below, because the vertex, because in this case here, it opens downward, the vertex represents the maximum point on the graph, which means this point is the maximum. So the graph starts at 2, negative 1 and goes down. But the x-axis lies above this point. So if you just are, if you're always observant and you always kind of think about things, you can save yourself some work and some time by realizing, okay, the vertex is here, it opens downward. Are there, the first question, are there any x-intercepts, right? First of all, that's the easiest way to determine whether there are or not, and see whether the parabola will intersect the x-axis, right? And one easy way to do that is just realize, hey, where's the vertex located? Is it above or below the x-axis? And does it open upward or downward? In this case here, because the vertex is below the x-axis and the parabola opens downward, we cannot have any x-intercepts, and we're done. And the answer is there are none. All right, so just keep that in mind. I know I went through a lot there, but it was good review and good practice. But always think about it before you start calculating things. All right, so C, so there are no x-intercepts, but what about y-intercepts? Well, there is a y-intercept. And by the way, here's another thing. The y-intercept is always going to be the constant term. Why? Because whenever you plug in 0, these two terms go away and you're always left with the constant term. So there's another tip, right? So a little shortcut things to think about that'll help you get to the answer quicker without having to go through the rigmarole of doing unnecessary calculations, right? So it's about critically thinking about things. So here, if you realize that, hey, I'm just putting in 0, so the y-intercept always reduces to whatever the constant term here. So immediately I know that the y-intercept is going to be at 0, negative 5. And we're done. See? Didn't have to do any real calculations there. Okay, now that we know all the information, we can sketch the graph of this, right? So again, all you have to do is what? Draw your graph, right? Draw your axes, right? Do your tick marks, okay? And make sure you just realize, okay, the vertex is at 2, negative 1. There are no x-intercepts. The y-intercept is at 0, negative 5, right? But then you can also use the axis of symmetry to find the other point, right? To find another point. Okay? Because usually you want 3 points, at least 3 points to sketch the graph of a parabola. So if we have 2, 1, so let's just do this. Let's just 1, 2, 3, 4, 5, and we'll do 1, 2, 3, 4, 5. And so we know 2, negative 1, so we're here 1, 3, negative 1, negative 3. And so here we got 2, negative 1, so we know our vertex is right here. We know at 0, negative 5 is going to be our y-intercept, so right there. Now, here's the thing. Where's the axis symmetry? The axis symmetry is right at x equals 2, right? So I know that there's another point that's a mirror image that's reflected across the axis of symmetry. So not only at 0, but at 4, right? So because this is 2 units away from 2, so we're going to go 2 units away from 2 on the other side, so that's going to be at 4. So we know we have another point that's at 4, negative 5. And so now we can sketch the parabola. And by the way, just to answer the next question they have is, what is the axis symmetry? The axis symmetry is just x equals 2. Remember, it's the x value of the vertex. That's what the line passes through. Now, what about the maximum value of the vertex? Well, that's the y value of the vertex. So in this case here, the maximum, in this case here, it's an absolute maximum. We'll talk about that later. But an absolute maximum means if you took the entire domain, it's the largest value of the entire domain of the function. So in this case here, it's the maximum of all real numbers on the graph. So here the maximum is going to be at -1, right? The y value. So the maximum value is equal to, well, here, I'll do it this way, is y equals -1. That's the maximum value. Or f of x. Or f of 2, I should say. Okay? Now the domain and range. Now the domain is always going to be all real numbers. The domain of a quadratic function, in fact the domain of all polynomial functions that we'll talk about later, are always all real numbers. Now in this case here, the quadratic, because we're dealing with a quadratic, the range here is going to be from the maximum value down to -infinity because it opens downward. So it starts at the vertex and goes down. So the maximum value of this point, of this, is going to be -1. So that's going to be the beginning of a range. So it's going to be from -1. Oh, how do I want to do this? Yeah, let's do it this way. So it's going to go from -infinity to -1. And oh, and by the way, I might have made this mistake before. I think I did. I think I might have put parentheses on this one. So remember, this is included. So the range should be a square bracket. Yeah, I did make that mistake in previous examples. So make sure you go back to your notes and note that. I think I accidentally put a parenthesis here for the range. Okay, it should be a square bracket because, of course, this point is included in the range. Okay, -1 in this case is included in the range. So that should be a square bracket. Okay, not a parenthesis. All right, that's it. Have a great day.